In this video we're going to look at enlargements. When a shape is enlarged, the angles stay the same, but the length of the sides of the shape are changed. An enlargement requires a centre of enlargement and a scale factor, so how much it's going to be enlarged by. The scale factor can be positive, negative, or fractional. When the scale factor is between 0 and 1, it's going to make the image smaller. So in the example above, if this was the object, then the image would be smaller, so that would be a negative or a fractional scale factor between 0 and 1. When a scale factor is larger than 1, it makes the image larger. So if the smaller triangle was the object, then the image is the larger one. And we'll deal with negative scale factors later. To enlarge a shape, first of all we mark the centre of enlargement. Then we draw a line from the centre of enlargement to one vertex. So one of these lines. We multiply the length of this line by the scale factor and extend it to the position of the corresponding vertex in the enlarged shape. So if this distance was 1 centimetre, then and it was a scale factor of 2, then we'd go to 2 centimetres. If this distance was 3 centimetres and the scale factor was 3, then we'd go to 9. If the distance was 5 centimetres and the scale factor was 7, we'd go 35 centimetres in total. And that's always taken from the centre of enlargement. And we'd repeat with all the other vertices until we have enough information to draw the new shape. Another way that we could do it is that we count the number of squares horizontally and vertically to the object point and then multiply that by the scale factor to get to the image point. So if we were to go 2 to the right and 1 up, a scale factor of 4 would be 8 to the right and 4 up. Example 37, enlarge shape P about the origin. So I'm going to mark on my centre of enlargement by a scale factor of 2. So I've drawn my construction line from the centre of enlargement to the first point. And what I can do now is measure this length of the line and then double it. And whenever I do that and draw it in a straight line, I end up at the point here at the top, and I can mark that with a point. I can do the same with this second point. So I've drawn the construction line and I can measure that length of the line and I can extend that so that it's twice the size, and the image point is going to be at the end of that construction line here. And again then I've drawn the construction line from the centre of enlargement to the last point, and I can measure that line and then double it, and I'll get the point will go to here. And then I can join the 3 points up, and that will form the enlarged triangle. And what we can do for a check is if we measure the base length of the original triangle, we can see it's 2 squares, and the base length of the image is 4. The height of the original triangle was 3 squares, and the height of the image is 6 squares. So we're good there. Example 38, enlarge Q about the point -4, -5, scale factor of 1/3. So first thing I'm going to do is mark on the point -4, -5. And then what we can do is we can draw construction lines and measure the distance from the centre of enlargement to each vertex. So I've got my 3 construction lines, and what I need to do then is measure the length of line, and then I have to divide that by 3 or multiply it by 1/3. And what I find is that the first point is going to be here, and then the next one I'll measure this line length and multiply it by 1/3, and it goes to here. And then the last point we'll measure the length of the line and then multiply it by 1/3, and we get here. What we can see then, whenever we join this triangle up, so we formed Q1, and as a check we can see that the distance of the base is 2 squares and in the original it was 6. The height in the original is 2, 4, 6, 9, and the height in the image is 3, which is a third. Now the other way we could have done it is we could have looked at the distance from each point on the original triangle to the centre of enlargement and multiplied that by a third. And by distance I mean the horizontal and vertical. So to get from the centre to the base point, we go right 2, 3, 4, 5, 6, and up 1, 2, 3. And if we third right 6 and up 3, we'd go right 2 and up 1. And that would be the same principle for all 3 points. Example 39, enlarge shape R about the point -2, 1 with a scale factor of 3. So I'm going to draw my construction lines. So I've drawn my construction lines, and what I need to do is measure the length of the line from our point to each image or each vertex, and then multiply that by 3. And we'll do the same for each point. So measure the length of line from the centre to each vertex and treble it. And we'll find that the points will go through this top point, and then -5, -5, and 7, -5. And we can join those up, and we get this shape, the large red triangle, to be R1. Again, we could have done it by counting squares. So to get from the centre to the top vertex, we'd go left 1 and up 2. And if we multiply that by 3 from the centre of enlargement, we'd go left 3 and up 6. To get from the centre of enlargement to the bottom left point, we go left 1 and down 2. So that means we'd go left 3 and down 6. And to get from the centre to the last vertex, we go right 3 and down 2, which means we'd go right 9 and down 6. Example 40, R double dash is also an enlargement of shape R. Work out the scale factor and the centre of enlargement. So to work out the scale factor, it's going to be new divided by old. So what we can do is we can work out the length of the new shape. So let's go for the height, and that'll be 1, 2, 3, 4, 5, 6 squares divided by the corresponding length, which is 1, 2, 3, 4. So it's going to be 6 over 4, which is 3 over 2, or 1.5. So the scale factor is 1.5. And that would be the same had we picked another side. So let's go for the base. The base in the image is 1, 2, 3, 4, 5, 6. And the base in the object is 1, 2, 3, 4. So we'd get the same ratio and the same scale factor. To work out the centre of enlargement, we need to draw our construction lines and see where they all converge. So we join up corresponding points and see where they all meet. So we've got our first construction line, which passes through the top of each triangle. And we've got our second construction line, which passes through the right angle in each triangle. And it's looking like the centre of enlargement is going to be at -5, -7. But we'll do our last one just to verify. So there's the third one drawn, and we can see that they do, in fact, all go through the same point of -5, -7. So the centre of enlargement is -5, -7. To describe an enlargement fully, what we need to do is give the name of the transformation involved. So in this case, it would be an enlargement. Then we need to also give the scale factor, and to work that out, it's the new length divided by the original, or the image divided by the object, and then the centre of enlargement, and that's by finding the construction points, or drawing the construction lines and see the point that they all converge through. So an enlargement, so for example, we have to give, it's an enlargement centre of 1, 2 and scale factor of 4. Example 41, describe fully the transformation which maps B onto A. So the first thing we're going to work out is the scale factor. And scale factor is the new over the original. And because we're going B onto A, that means B is the original and A is the new, or B is the object and A is the image. So if we look at the base length of B and the base length of A, we can see it's 1/2. We could also have done the height, and the height of B is 4 and the height of A is 2, so then it would have been 2/4, and either way it's still a half, so the scale factor is 0.5. So we've got an enlargement. We'll just write that down. So we've got an enlargement with a scale factor of 0.5, and then what we need to do is work out the centre, and to do that we'll draw our construction lines. So I've drawn one through the top of each triangle. I'm going to go one through the right angle now. And then we'll do one again through the front point. And we can see that they've all converged through this point here, 1, 3. So we know it's an enlargement, scale factor of 0.5 and a centre of 1, 3. Whenever we're enlarging with a negative scale factor, we do the same method as before, only we draw our lines on the opposite side of the point. We also talked about if the distance from the centre of enlargement to a point was 3 right and 4 up, the negative would then make it go in the opposite direction, so it would be left and down. So negative scale factors put the image on the other side and in the opposite direction. So example 42, enlarge the shape S about the point 3, 1 with a scale factor of -2. So we'll mark in our point 3, 1, and then we're going to draw our construction lines again. So what we do is we measure the distance from the centre to the point, and we can see that's 1 square diagonally up. So if we multiply that by a scale factor of -2, it's going to be 2 squares diagonally down from the centre, which is going to be at 1 minus 1. We'll go from the top then. And if we measure the distance from the centre of enlargement to the first point and then multiply that by -2, now in this case we could consider it to be going right 1 and up 4. So if we do that with a -2, it's going to go left 2 and down 8. And we're going to end up at the bottom. So we'll mark that point. And then lastly, we can draw our construction point, construction lines, and extend it on. And again, we can measure the distance with a ruler, or we could see that it's right 3 and up 1. And if we do right 3 and up 1 and multiply it by -2, we'll go left 6 and down 2. So the image point will be at -3, -1. And we can join that triangle up and label it S1. Example 43, enlarge shape L about the point 0, 2. So 0, 2 is here, and about a scale factor of -1/6. For this one, we're just going to count squares because the construction lines will go through these, so it's a little bit awkward. So to get from our centre to the top, we're going to go left 6 and up 6. If we multiply that by -1/6, we'll end up going right 1 and down 1. So the first image point of the top one is at the point 1, 1. If we go from the centre to the bottom point, we go right 6 and down 6. And if we apply a scale factor of minus a sixth, we'll go left 1 and up 1. And we get our second point to be here. And the last one then, to get from the center to the point, we'll go left 6 and down 6, which means go right 1 and up 1. So then the corresponding point of the bottom corner is here. And we can join those up with the construction lines. And we've got the triangle L1. The width of the base of this triangle is 12, and the base of the image is 2, which is a sixth, and it's in the opposite direction. The height of the image is 2, and the height of the object was 12, so again it's a sixth. So it looks like we're good here.